From the Northern Sea Route, we will move on to the ice. So there are different types of ice and their classifications we will see. Then we will also look at the ice class ships and other things. So there are different types include new ice, that is 1, Nilas is 2, young ice, thin first year ice, medium first year ice, thick first year ice, then second year ice, multi-year ice and glacial ice. So there are 9 different types of ice are there. The classifications, that ice numeral values are given from 1 to 9. So how do we know what are the different types? So the new ice means it is less than 10 centimeter thickness. So the descriptions are given here. The Nilas, which is type 2, is again less than 10 centimeter thickness. Some examples are the subdivisions for the new ice include frizzle, grease, slush and sugar. For the Nilas, it is thin elastic crust, bends from waves and matte surface. The young ice is basically 10 to 30 centimeter thickness. They have grey ice and the grey white. The thin first year ice is 30 to 70 centimeter thickness. They have stage 1 and stage 2. The medium first year ice is 70 to 120 centimeter thickness. The thick first year ice is greater than 120 centimeter thickness. The second year ices, they survived at least one melt season. They have higher freeboard, smoother surface and greenish blue puddles. Multi-year ice is basically they survived more than one melt season. Glacial ice is originated from glacier that called into the sea. So these are all the different types of ice and their classification. There is also other types which is called the decayed ice, rigid ice, traces of ice, pack ice and fossil ice. Some countries also use the classification A, B, C or D. So type A means thick, difficult ice, which is similarly multi-year ice. Type B means they are moderate thickness, significant for navigational challenge, example first year ice. See, the type A, B, C, D are basically used for the sailors, because when they want to traverse through that, they need to know what type of the ice they are actually going to pass through. The moment they know that, then they exactly can identify what is the best thing they can do. Similarly, type C is thinner, manageable ice. Type D is light ice, often less significant impact. Type E is very light or trace ice, generally not counted in navigation assessment. So what is the decayed ice? This is multi-year, second year, first year or medium first year ice with thaw holes or rotten ice. So this is the major thing which is called as that is already decayed. So for example, when we say decaying means something is dead. So there is holes or rotten in the ice. So that is what is the decayed ice. This is impact on ice numeral calculation is basically it may be increased by 1 if it is present. So we will look at what is the ice numeral calculation in the later part. The rigid ice is ice concentration having 6 to 10 or greater with 3 out of 10 or more being deformed by ridges, rubbles or hammocking. So this is what is called the ridge ice. The trace of ice means less than 1/10 of the concentration of the ice in that entire area. For example, I travel through like 100 kilometers, square kilometers I want to travel. If the ice is less than 1/10 of that area, then that is we say like traces of ice. The sailors say it is a traces of ice. What is the pack ice? This is a large chunk of floating ice broken from larger ice masses covering large water sections. Frizzle ice is basically ice flakes or needles suspended in water with minimal effect on vessel but may cause resistance and abrasion. So these are all the very important thing a sailor should know. And we have a brash ice, floss, cake ice and landfast ice. The brash ice is loosened fragment of ice typically less than 3 meters thickness and 2 meters in diameter. Floss are basically flat pieces of ice sheet spread over a vast area, larger breakup from the pack ice with a small thickness variation. Cake ice is basically a like a cake, circular piece of ice with a certain thickness welling up from the mean sea well level. And landfast ice is they are harder forms of the ice attached to the shore or ice wall, replenishing over years and dictated by the surrounding sea levels. So we talked about ice, now we will talk about the ships. So what are the different classification of polar ships? We have PC1, PC2 up to PC7 we have. So the polar class classification means PC1 has the highest capability of navigating in all ice conditions. They can operate in multi-year ice and in areas with a thick ice also. These kind of ships can be operated. If it is a PC2 class, then they have strong capability in severe ice condition. They are designed for first year ice and can handle rigid ice. PC3 is basically moderate capability for ice navigation. PC4 is a limited capability. PC5 has much lower capability intended for minimal ice. PC6 is designed for navigation in light ice condition. PC7 is minimum ice class vessel for operation in open water with possible light ice present. So these are all the different types of ice and the which ship can actually traverse through those areas are given. We talked about the ice numeral. So how do we calculate the ice numeral? The ice numeral is a numerical value that indicates the concentration and the type of ice in a given water area. So the ice numeral is basically used to assess the risk posed by the operation in a given ice regime and is determined as follows. In, that is ice numeral, is equal to C1 into IM1. So where In is the ice numeral, C1, C2, C3 are the concentration in tenth. That's what 1/10, 2/10, 3/10, like that they will calculate. They will actually look at the C and say how much ice is actually covered, because from our eye also we can roughly find it out how much ice is actually covering that area. So based on that, this ice numerals calculations can also be calculated. And of course we can also use the satellite to exactly know how much ice is actually present in the sea. So the C1, C2, Cn, etc. are the concentration of ice types within the ice regime, and IM1, IMN are the corresponding ice multiplier for each ice type. We had seen 9 different types of ice types. So based on that, every ice type will have a particular numerical value which can be used for the calculations. What are the factors that affect the ice numeral? One is the ice concentration. The percentage of ice cover in a given area usually expressed in tenth. That's what I said, like 1/10, 6/10, 5/10, like that people say. Ice type is the different type of ice, multi-year, first year, brash ice, etc. They have different impact on the ice numeral. Deformation means the presence of rigid, hummocked or deformed ice that can affect the calculation of ice numeral. Environmental conditions like temperature, wind and the ocean currents also affect these values. The old ice presence, that means encountering old or decayed ice, may require adjustment to the IM for navigational safety, because we know the biggest story, everybody knows about the Titanic. So the Titanic was hit by an iceberg. So that is where the safety was taken at the after the Titanic accident. Everybody started looking at the various ways how a vessel can be safely traversed through these icy conditions. So what is the ice multiplier? This is basically a factor that is used in the maritime navigation to account for the additional resistance and challenges that the ice condition impose on a vessel's movement. So when you are traveling through, if you are traveling through the road, we generally look at potholes or other things that are present in the road. Otherwise, if you are traveling through a sea, you are actually here looking for the ice. So it is typically applied to the vessel speed, fuel consumption or other operational parameters to provide a more accurate assessment of performance in icy water. So how fast you can travel, that is the simplest thing, and how efficiently you can also travel. So this can be calculated based on the ice multiplier calculations. So how the calculation is done? The ice multiplier is determined based on various factors including the ice type and concentration, ice thickness and deformations and environmental conditions. These ice multiplier can vary depending on the specific conditions and the vessel types. Different vessels may require different multiplier based on their hull design, ice breaking capability and the operational profile.